Hey everyone! In this video, we are going to discuss about some of the very basic components that we are going to use throughout this course. So there are basically three components that we will need in all of our projects, which are LED, breadboard and jumper wires. Here first I will explain you about all of these, then I will show you that how they work. So first of all we have the LED. It is also known as a light emitting diode and it's just a semiconductor light source that emits light when current flows through it. Here it looks like this one, the picture on the left side where we have a small light bulb on the top and there are two wires coming out of it. And as you can see in the right picture, these two wires are known as anode, which is also referred as a positive terminal, and cathode, which is also referred as a negative terminal. When the LED is connected to the power source, the current flows from these two wires and the LED will glow. Here, when you connect the positive terminal or anode of the LED with the positive terminal of the power source and the negative terminal or cathode to the negative terminal of the power source, the current will flow through the LED and it will glow. As you can see here in this example, when the positive terminal of the LED is connected to the positive terminal of the battery, the LED is glowing. And they do not need high voltage supplies. You can even make them glow with 1.5 volt of supplies. However, the most efficient voltage supply is 3.3 volts. And as you can see here, I have used AA batteries and AAA 1.5 volt batteries. So you can power up the LED by any kind of batteries. And in case if high voltages will be used with the LEDs, say more than 3.3 volts and without any protection, then it will burn them out. Like here I have used three 1.5 volt battery cells on the left and one 9 volt battery on the right. Both of them have burned the LEDs, as you can see here in these demonstrations. So we have to take care of proper voltage supply to the LED. We must make sure the supply that they are getting is enough and less than the supply that can burn them. However, there is one more way by which we can make our LEDs glow safely with high voltages. That is with the help of resistors. We can use the resistors with the LEDs and they will absorb the extra amount of supply and let pass the required amount to the LED. As according to Ohm's law, V is equal to IR, where V is the voltage, I is the current and R is the resistance, which means current is directly proportional to the potential difference between the two terminals. What I mean here, like here in these two pictures, in first one I have a 1.5 volt of battery cell, while in the second one I have a 3 volt battery cell. With the first one, the LED is glowing with lower brightness, while with the second one, the LED is glowing with higher brightness. So it means that higher the voltage supply or the potential difference between the two terminals, higher will be the current flowing through the circuit. That's why our LED is glowing with more brightness with a 3 volt battery cell. Now, this same law also tells us that voltage and current also depends on resistance, as V is equal to IR. So by changing the resistance, we can change the amount of current flow in the circuit. Here I have shown you a simple demonstrations of Ohm's law, and as you can see here, V is the potential difference which makes the current flow through the circuit, and resistance always try to block their path. So by using the resistance, we can change the flow of current according to our needs. So we use these resistors in our circuits to protect our LEDs and other components from high voltages and currents. As you can see in these two demonstrations, we have the same circuits that we have before where our LEDs burned, but this time we are using a resistor and we have our LED safely glowing. As you can see here in the first one, we have 1.5 volt of battery cells, and in the second picture we have a 9 volt battery, and again our LED is safely glowing. So this is how resistors protect our components. Now these resistors can have different values which you can easily find out using their color bands. Each color band represents a specific value which you can refer from this table. Like here I have an example on the right where I have this resistor in which we have 4 bands: brown, black, brown and gold. Now how we can find out the value of this resistor? We will check the value of each of these bands in these particular columns in this table. Like first we have the first band which is brown here. So we will check the column first band in which we have the value of brown 1. So our first digit will be 1. Our first two bands are our first digits, third band is our multiplier and fourth band is our tolerance. Now after the first digit, our second digit will be the value of black, which is in second band 0. As you can see here, we have the black on 0. So now our digits are 1 and 0, which is 10. After that one, we will check the multiplier, which is the third band, that is brown again. So the multiplier will be 10 again. As you can see here in the third band multiplier, the value of brown is 10 ohms. So the total value of our resistance will be 10 multiplied by 10, which is 100 ohms. Then in last we have the tolerance, which is plus minus 5% for gold. Now by using this table, you can find the value of any resistor. It can be 57 ohms, 57,000 ohms, mega ohms, anything. You just need to check the color bands and then you can use those resistors. Now here comes a question that why can't we just directly use low voltage supply instead of using resistors? So most of the times there are more than one components in this circuit and we can't use different batteries for each of them. So we just use the maximum supply required and distribute it with the help of resistors. As you can see here in this demonstration, we have a DC motor and a LED, and we have distributed the required supply to the LED using the resistor. Now after this one, let's move to the connections. So you must take care of connecting the proper terminals. Positive terminal of the LED must be connected to the positive terminal of power supply, and the negative terminal of the LED must be connected to the negative terminal of power supply. As you can see here in these pictures, first I have connected the proper terminals. Here the LED is glowing, but after that one I have changed the connections and connected the positive with negative and negative with positive, but the LED is not glowing. And in the third picture, I have used a 9-volt battery, but I have connected the LED with opposite connections. Here the LED is neither glowing nor it's burning because the current will not flow through it. Now after this one, how we can find out these positive and negative terminals in the LED? We have just a small bulb on the top and these two wires. So how we can spot the positive and negative terminals? So there are basically two methods for that one. First is, if you look closely, you will see that the length of these wires are not equal. One of these is larger and another one is the smaller one. Here the larger one is the positive terminal, while the smaller one, it is the negative terminal. The negative terminal is also known as ground. Now this method is not so efficient because sometimes we do not have the length of the wire. We have soldered it somewhere and we can't see the length. So there we use our second method, which is if you look closely inside the LED, you will see there are two elements in that. As you can see here in the right picture, one of these elements is larger one and one is smaller one. And as you can see, the larger one is the one which is connected with the smaller wire, while the smaller is the one which is connected with the larger wire. So our larger element is the negative terminal and the smaller one is the positive terminal. So you can just simply remember it. Smaller is for the positive and larger is for the negative. So this is all about the LED and I hope you got it. After this one, we have the breadboards. A breadboard or proto board is a construction base for prototyping of electronics. They are used to help you connect components to complete your basic circuit. They look like this one, as you can see here, just a white plastic board with a lot of ports. Now let's understand a little more about it. So in very simple words, it is a thin plastic board used to hold electronic components like transistors, resistors, chips, etc. that are wired together. They are used so we do not have to solder the components again and again. With their help, we can make temporary connections which can be changed anytime. We can just take the components and insert them in the ports available on the breadboard. You can take them out anytime and can relocate at different positions easily. It makes circuiting really easy. Even if you are a complete beginner in electronics, you can easily work with them. There are three types of breadboards which are classified according to their size. It includes breadboard mini, breadboard small and breadboard, which you can see here in the pictures. Now here on these breadboards, the port lanes are also known as rails, and there are two types of rails on the breadboards, which are component rails that you can see here highlighted in the middle, and the power rails, which you can see on the outer ends. However, the Breadboard Mini has only component rails but no power rails. And these rails are nothing just pair of common connection metallic strips. If you look behind the breadboard, you will find these kinds of connections there. All the component rail ports are common connections in pair of 5, while the power rails are a one complete common connection. And all these common connections, they are nothing just these metallic strips, which you can see here. These are known as metal clips and they are designed to hold the components. Whenever you insert any component there, they will perfectly hold it. If you connect multiple components on the same common lanes, they all will work together. Like here in this example, we have 2 LEDs in component rail and 8 LEDs in power lane and only one power supply at the upper power lane. But they all are glowing at same time. So this is how the breadboards expand our circuits. And if you are confused with these breadboards, then you don't need to worry about anything. You will get more and more comfortable with these when we will work with them. Now in last, few more things about the breadboards that you need to know. So first one is, there is a line in the middle of the breadboard which splits it in two halves. It is known as dip support and is present there so that we can fit ICs on the breadboard. As you can see here in these pictures. So whenever we need to fit an IC on the breadboard, we use this dip support. Now after this, you may be thinking that why this electronic component is known as a breadboard. So it comes from the early days of electronics when people literally drive nails or screws into wooden boards on which they cut bread just in order to connect the circuits. So this is how it got its name breadboard, and this is all about it. Now after this one, we have the jumper wires. So they are electrical wires or group of them in a cable with a connector or pin at each end. They are normally used to interconnect the components of a breadboard or other prototype or test circuit internally or with other equipments or components without soldering. They we use the breadboards to hold the components and we use these jumper wires to connect them with each other. With the help of jumper wires, we can make temporary connections anytime and anywhere in this circuit and can take them out without much issues. Now, there are basically two types of ports in these circuits, which are male port and female port. Male port look like this one, where we have a pin at the end, while female port look like this one on the right, where we have a port in which we can insert that male pin. Now, based on the ports a jumper wire has, it can be of three types: male to male jumper wire, male to female or female to male jumper wire, and female to female jumper wire. In male to male jumper wires, we have the male ports at each end, as you can see here in the picture on the left, and in the male to female or female to male, we have one female port at one end and one male port at another end, as you can see here in the middle picture. And then in last, we have the female to female jumper wires, in which we have female port on both ends, as you can see on the right picture. So this is all about the jumper wires. You will also learn more about these when we will actually work with them. Now here we are on the board, and here I will show you that how basic components looks like and how they work. So we will begin with the LEDs. So they look like this in real, and you may have already seen these in a lot of devices. We can simply power them up by connecting their terminals with the power supply. So here I have a power supply in which my red wire denoting the positive terminal and black is the negative terminal. So when I connect these with the terminals of LEDs, my LED will glow, as you can see here. Now here, if you look closely, you will find that one of these wires is longer in length and one is shorter. So this longer one is our positive terminal and this shorter one, this is our negative terminal. And also, if you look closely inside the LED, you will see there are two elements. One is larger and one is smaller. Our smaller one is the positive terminal and the larger one is the negative terminal. Let me show you. So here we have the smaller element and longer wire. So this is our positive terminal. So when we connect this with the positive terminal of our power supply, and when we connect the negative with the negative one, our LED will glow, as you can see here. Now there are different color in these LEDs, like this one is red, that was blue, here we have a green, I guess, so there we go with green, and here we have a colorful one, so that's also possible in these LEDs. Now after these LEDs we have the resistors. They look like this one, as you can see here. Now we can just use them with the high voltage supplies. So simply take the LEDs, then take the resistors, connect them with the LEDs like this one, and just connect it to the power source. So here we have this one positive terminal and this one our negative one, and there we go with the LED safely glowing with a 9-volt battery. Now after the resistors we have the breadboards. So here we have all three breadboards: breadboard mini, breadboard small, and the breadboard. Here we have the component rails, and here we have the power rails in this also. While in the breadboard mini we have only component rails, which all are in pair of 5 ports. And when you look from back side, you will see here we have these metal clippers. Similarly on this breadboard small. Now here, if you take one of these, then you will see here we have these clippers, just like we have seen in presentations. Now after this one, let me put it back. Now here we have some demonstrations of these breadboards. So here in this breadboard mini, I have connected two LEDs in these component rails, and when I power them up, just like this one, there we go with the LEDs. So both of them are glowing with only one connection here. And similarly in this power lane here, when I connect the power source in the power lane with these 4 LEDs, then you will see here all of them will glow. So here we have all these LEDs glowing. So these are our breadboards. Now after these, when you need to connect the ICs on these breadboards, connect that one here in the middle and just insert it. There we go with the dip support here. I hope you got it. Now after these, here we have the jumper wires in last. So we have 3 types of jumper wires, in which we have 2 types of ports. These female ports here, which you can see, and these male ports here. And this is our male to female or female to male jumper wire. Here we have a male to male jumper wire, in which we have male ports on both ends. And here we have a female to female jumper wire. You can just simply use them by connecting these like this one. Just insert them in the ports like this one, and then you can connect it anywhere you want to. So this is all about the basic components. I hope you got all of these, that what they are and how they work. And thanks for watching. I will see you in the next video.